So hello everyone, hope you're doing good and welcome back to my channel. Today we are at the first day of the June Lady Leetcode Challenge, and once again congratulations to all those who have successfully tried their best for the Mini Leetcode Challenge. I'm not saying you should be solving each and every question. I understand that there are some questions which are really tricky, and without understanding the tricks you may not be able to solve them. A trick in the sense like Leetcode only accepts a particular kind of solution for those questions, so definitely will not consider them. And see, the idea here is you should be showing up every day. Like, you should be learning at least something from a problem, right? And I understand there are some questions you which I don't think a beginner, as a beginner, or even sometimes as an expert, you will be able to solve in the first attempt. Okay, so the only idea here is show up every day and learn something new. That's the only thing which I should say. And congratulations to all those who have done that for the last month. And today we are at day one of the June Lily Code Challenge. And let's see what the question is. It's a really interesting question. See, when you see this kind of matrix, there are so many ways to solve it. And previously also we have solved so many questions of this variety, but this question is somewhat different, and and somewhat easier also compared to all that. Okay, let us see how we are doing it. And it's question 1091. Okay, shortest path in binary matrix. Okay, as the word shown here, binary matrix, so which clearly means that there are going to be two kinds of values here, zeros and ones. Okay, we need to find the shortest path between what nodes we need to find shortest path. We'll be seeing in that question. Okay, so first thing they've given is it's a n cross n matrix. That means one thing is very clear, it's a square matrix. Okay, they are calling it as a grid. That's fine. Return the length of the shortest clear path. Okay, they are defining something called the clear path. Okay, we will see what it is. Okay, we need to find the shortest clear path in the matrix. So matrix is given to us, we need to find the shortest clear path. Okay, if there is no clear path, return -1. So one thing is very clear: if we are not able to find a clear path, we are returning -1. Okay, so let us see what a clear path now is. See, so basically they are defining clear path, okay, as the path between top left cell and bottom right cell of the matrix. What that means is the path between 0 comma 0. That means the leftmost, you can say this way. Okay, topmost leftmost cell. Okay, which is 0 comma 0. If you understand the indexing of how a matrix 2D matrix is done, you will be definitely be knowing what is 0 comma 0 index means. Okay, in a matrix, a two-dimensional matrix. So it's basically represents the topmost and the leftmost cell. Okay, from there to the bottommost and the rightmost cell, which is represented by n-1 comma n-1. Okay, so this is we have to find a clear path between these nodes. Okay, that means the shortest possible path between these nodes, and they've given some more conditions. That means all the missing nodes for the path are zeros, and they are given 8 dimensions. So that means we can move 8 directionally. Okay, I will quickly show you what all these things means. See, uh, come to this example. We need to find a path from this. I hope my mouse pointer is visible to you. Okay, so from this node to this node. Okay, the first condition here says that all the nodes in our path should be zero. Okay, that means the idea is we should not consider those nodes which are one. Okay, which are numbered one. They should not be included in our path while finding the shortest path. Okay, so as you can see here, this is one kind of shortest path. Let us first talk about only paths, then we will come to what could be the shortest path. Okay, so you can move rightmost, then you can move totally bottom, directly to the bottom. That is one path, or you can tweak this diagonal thing also. The second point which they are trying to say here is that the path which you are going to take, while finding the shortest path, it could be 8 directionally, connected. What it means is, see, normally in I remember when we saw this kind of question previously, they had given 4 directionals. Okay, that means we can only move top, bottom, right, and left. Okay, in this case, as you can see here in this image, you can move diagonally also. You can also move diagonally. Uh, Remember one thing: when we see all these things we understood, but what is the meaning of the shortest path? Okay, they have given a short hint here. Length of the clear path is the number of visited cells in this path. Okay, so see, what is the question? We need to find the shortest clear path. Okay, shortest clear path. Now shortest means obviously we have to find as much minimum as possible of what, of the length of the clear path. Okay, so that means we have to find a path such that the number of visited cells in this path is minimum. You can see here how this diagonal thing helps us. See, for example, if you calculate the number of nodes visited in this particular path, see, 1, 2, 3, and 4. Okay, now suppose this diagonal thing is not there. Okay, we move to, towards the right till the last cell, then we move to the bottom till the last cell. So if you see 1, 2, 3, 4, and 5. Okay, 4 and 5. In this case, it was 1, 2, 3 and 4. So you can clearly see the diagonal thing helps us. Okay, whenever the diagonal thing is given, it will also optimize the solutions further, and it will reduce the path. Okay, because diagonally we are avoiding to go to this matrix, this particular cell. Okay, we are avoiding to go to this cell. We are directly jumping from here to here. Okay, so it saves us one unit of distance. Okay, that is the basic idea. So I hope this question is clear to you. We have to find the shortest path between the 0, 0 node to n minus 1, n minus 1 node. Okay, in the two-dimensional matrix, our shortest path should only consider nodes which are numbered 0. That is the first point. The second point is that see, while finding the shortest path, we can consider 8 directionally connected paths. Okay, that means from one node you can go to its diagonal node as well as all the adjacent nodes. Okay, all that kind of adjacent nodes, even the diagonal ones. Okay, that is the basic idea. And here I have covered all the points in the question. Okay, and finally they have given a hint that see the ultimately you have to return the minimum path, right? See, if you see the answer is going to be the number of nodes visited in the path. Okay, the answer is the number of visited nodes in this path. Okay, we have to find the shortest one of that. Okay, this is the question. I hope it's very clear. And see, you can trace these examples also. It's very self-explanatory. You can clearly see this path. The length is 4, 1, 2, 3 and 4, and that's what the answer is 4. And in this case, it's a two-dimensional matrix of your length 2. You can clearly see from 0, 0 to this last index n minus 1, n minus 1. There are only two. You can directly go from here to here. Okay, so there are only two paths only two nodes involved in the path. Okay. Now coming to the solution. See, one thing you must have noticed here is that it's a binary matrix. Okay, there is only 0 and 1 values. Okay, 0 values and 1 values. So the first thing that came to my mind is that breadth first search. Okay, breadth first traversal or breadth first, or whichever way you call it, BFS. Okay, why BFS? Because see, try to understand this. As I told in this example, see, here we are trying to find the minimum possibly. Okay, so what? See, just try to understand. See, I can come to this 0 from this also. In the same time, I can come to this 0 from this also. Okay, but which is more relevant to me? As soon, see, that means I want to find the shortest way to reach here. Okay, so how BFS will help me? In BFS, if you remember, okay, BFS means we will be proceeding. First, we will explore all the adjacent nodes, and then we will be proceeding all the further adjacent nodes. That means in the first iteration, we will be exploring all the adjacent nodes which are at distance 1. In the second iteration, we will be exploring all the adjacent nodes which are at distance 2. Okay, such that it will continue. Okay, in that case, if we reach the last node let us say in second or third iteration, then that distance is going to be the answer. Okay, that is the basic idea. That's why I feel DFS will be the most appropriate approach here. And okay, as I explained, there are some ambiguities here. While understanding, you will be doubting why BFS is being used. We address them while we solve the question. Okay, so let us jump to the code now. See, I first taken out n. Okay, because n is not directly given in the question. We are just given the grid. So as you know, it's n cross n grid. So take along any one direction the length, you will get it. Okay, that is the basic n. Then we are doing something which is very very important. Okay, we are trying to check if the first node is 1. Okay, or the n cross n node n minus 1 n minus 1 node is 1. Because see, the path should only involve zeros. Okay, the path should only involve zeros and should connect with 0, 0 and n minus 1 n minus 1 node. Okay, if they themselves are 1, that means there cannot be a path. That's why we're returning minus 1. Please try to understand here. This is the source node from which we will be starting the shortest path finding. Similarly, this is the last node which will be ending the shortest path finding. Okay. So if these nodes itself are not 1, that means these nodes itself are not 0. That is, we cannot include them in our path. That means this a particular thing is not possible. Finding a path between these things is not possible. Okay, because they cannot be included in the path. So we're returning minus 1. Then comes the edge case where n is 1. Okay, the kind of solution which I've implemented, forces me to declare this kind of edge cases separately, because I will explain why I am declaring separately. But whenever n equal to 1, okay, that means only single node is present. That means that itself is the source node and that itself is the last node. So we are returning the same number 1, okay, because how many paths we have, how many cells we have visited. So only one cell we have visited. That's the idea. These were the edge cases. Now coming to the most important part, the directions part. Okay, I'm declaring separate array for directions. Okay, as you can see, there are 8 elements in it. What are the elements? See, these are the ones which represents moving along vertical and horizontal directions. Okay, these are these 4. Okay, moving along horizontal vertical direction. That means top, bottom, right, and left. Okay, the next 4 is, you can see, they represent moving along the diagonals. Okay, How moving along the diagonals? That means just imagine how the diagonals are. Okay, they can be along the first you can take right and then left. That means the diagonal along that direction. Okay, and similarly all the other ones. Okay, there are 4 diagonals possible. Okay, for each node. That is what it is. Okay. Then, as you must be knowing, whenever we do a BFS search, um, if needed, we will be also be using a visited set. That means the nodes which are already visited, we will not be visiting them again. Okay. The idea here is, see, as I have told you already in see, BFS means after the first iteration, all the nodes which are at distance 1 will be explored. Okay. Similarly, after iteration 2, all the nodes which are at distance will be explored. Okay. The idea here is, see, for example, in this case, I have already visited this node at distance 2. Okay. At distance 2. Now, suppose come from here to here also, then it will be slightly longer distance. Okay. Now see, I am talking about this 0. Okay. 1, 2, and 3. This is at a distance 3 from the source. Okay. Now, if I follow this particular path, see, from here I'm going fully to the right and I'm following here, then it will be distance 4. The idea here is I should take the shortest one. Okay. That's why once a node is visited already, that means let us say I visited in iteration 3, then if the same node is again coming in iteration 5, I should not consider it. Why? Because here we want the shortest distance, right? If a previous iteration is already discovered, that means it would have definitely a lesser distance from the source in the previous iteration, right? So we should not, touch it again. We should not explore it again. That is the basic idea. Once a node is visited, it should not be explored again. Now we are ready to start the BFS. Okay, so these are some of the important points we should keep in mind. This is how I've implemented. Okay, if a node value is 1, it should not be inserted into the queue. Okay, as you know, the basic how the BFS works, there will be a queue. Until the queue is empty, we'll be exploring each and every node. Okay, we will pop a node out, we will explore all its neighbors. Okay, means we will explore its neighbors, then we will explore, like, insert those neighbors in our queue, and so on. It will going on. Okay, till the queue is not empty, right? That's why it will be done. So the idea here is, because we have to follow a path of only zeros, the path should not have any node of 1. That's why will not be including them in our queue, right? Next thing is, already visited node will not be explored again. That why we are doing that? Because if it is explored, that means in the previous iteration would have a much lesser distance from the source, right? So why to include a bigger path now, right? So we will not be exploring again. Okay. Let me quickly give you the dynamics of this. Okay, it's something very simple. Okay, but please pay attention. The first node tells the number of nodes visited till now. Okay, when we are starting for the first time, we will be at 0, 0. That means we are considering that node as a visited one. So the first node, initially the number of nodes visited is 1. Okay, the next two indices represents the x comma y direct index of the particular node. Right, it's 0, 0. Okay, I am in my visited set. I am including this 0, 0, because now it's visited, right? Because I'm going to start from it, that means already visited, right? So that I'm including in my visited set. Okay, now this particular loop will run till all the nodes, till the queue is not empty. Okay, initially only 0, 0 is present in the queue. Okay, already told you, first one is the distance, and that is the number of nodes visited till now. It's also the distance, right? And similarly, the next one is the x and y index of it. Okay, then what I will do is, I will this value will run till the queue is not empty, right? First, I will pop a element out. That means in this case, I'm popping the 0th index out. Okay, I'm popping the 0th index out. Okay, what are the, see, it has 3 values, right? These values will be mapped to these 3 variables. Okay, first is the distance covered, then the cx means, that means the current x, and the current y. Okay, that's it. Then we will be going on, we will be iterating over the directions. What is direction? This is the direction set here, right? Here you can see that each index has 2 elements. Okay, one for x and one for y. That means the ith element and y, the th element will be capturing each of these. Okay, so for example, -1, 0 will be captured through the I and j. Okay? Then I will be finding our next x and next y. Okay, nx and ny. Okay, next y. How I will find them? For the current x, I will be adding I, and for current y, I will be adding j. Okay, to get next x and next y. Remember one thing: when we are doing like that, it could be possible that we are moving out of the current, the matrix has some index, right? We are moving out of the border of the index, border of the matrix. Okay, so we are checking if the nx, that is the next x, is within 0, n. Similarly, if the next y is within the range 0, n. Okay. Similarly, if the suppose these are true, that means if the current nx and ny represents a node which is inside our grid. Okay. Next thing is, I am checking if the values of the node represented by nx and ny is 0. If it's not 0, as I told you, I will not be exploring it further. Okay, because here we need to consider only those nodes which have 0 value, right? So we will be doing that. Okay. Next is we are checking if the nx and ny is already in visited. If it is already visited, we will not be exploring it again, right? If all these conditions are true, okay, if it is within the matrix and its value is also 0 and it's not explored also, then we'll be checking if this is the last node. What is the last node? That means if it is represents the n minus 1 comma n minus 1 index, okay, that is the rightmost bottommost node. If that is the case, we will be returning the distance covered plus 1. Remember, distance covered is for the current node, okay, cx and cy. When we talk of nx and ny, we are supposed to add 1, okay. That's why I'm adding 1 here, okay, because nx and ny represents the last node in this case, so I'm adding 1, okay. This is the idea here is I am not going to insert this in the queue again, okay. Once I find the node, I need not insert it again in the queue, okay. So I should just return the answer. That is the basic idea. If this is not the last node, then I will be adding it to my visited set. The idea here is before inserting in the queue, I will be adding it to my visited set, okay. Next, I will be appending into my queue now, okay. See, breadth first traversal, I hope you understand what it is. uh, in the first iteration, we will cover all the nodes which are distance 1, okay. Then we'll be adding its neighbors into our queue. Okay, that means in the second iteration, all the nodes which are at distance will be explored. Explored in the sense we will be going through all of their adjacent nodes and we will be adding them into the queue. Right? This is that path. Okay, I am adding the adjacent nodes of the current x and current y. Okay, this is the one, current x and current y. So see, nx and ny represent all the nodes which are adjacent to cx and cy. That is current x and current y. Okay. So I'm inserting them into the queue now. Remember this thing here. I am adding the distance covered plus 1, because see, they clearly mentioned here the distance in this case is going to the path, length of the path in this is going to be number of visited cells. Okay, whenever we are visiting a new cell, we have to add 1 to it. Okay, so the distance covered plus 1, or you can say the nodes visited plus 1. Okay, whichever way you call it, you can do that. Okay, so you can clearly see here this is the only return statement in this whole program. Okay, this is the only return statement in this whole program. That means once we have visited the last node, okay, once we approach the last node, we will be returning the distance covered plus 1. Okay, if the whole value ends and we do not get till the last node, that means there is no path possible till the last one in the sense and minus 1 comma minus 1. Okay, in that case we'll return minus 1. Okay, you might be knowing this also, that we are returning minus 1 in the this also. That means if the first node, that is 0 comma 0 node, or the n minus 1 comma n minus 1 node is represented by 1. Okay, that means it cannot be included in the path because the path should have all these 0 nodes only. Okay, the path should have all 0 nodes only. Here it is. Okay, that's also we are returning minus 1. Yeah, here it is. Yeah. Yeah, friends, that was all. And see, the like, I felt BFS is better because see, the idea here, the see, if you are given this in the interview, the explanation which I will expect from you is that because see, BFS means in the first iteration I will get all the nodes which are distance 1. Similarly, in the second iteration I will get all the nodes which are distance 2. And this is basically what I want for this question, right? Once I reach the last node, I should be reaching in the shortest way possible, and then I should be returning that. Okay. Remember, there are many ways to visit the last node. There will be some longer ways also, but BFS will give me the shortest path in this case. Okay, that's why I will be returning that. So yeah, this is the BFS approach, friends. There may be many ways to do it, but remember, technically speaking, BFS is the best way for applying it. Okay, best way for you know reaching this kind of solutions, because the question exactly demands that, right? So yeah, friends, that was all for today. If you have a better approach, please do comment below and let us discuss further. Thanks a lot.